Hello. All right. So almost last part of the unit, we're going to go over one more thing before the unit test, but we are looking at metamorphic rocks. So first we looked at minerals, where all the rocks are made from. Then we looked at igneous, and then we looked at sedimentary. Remember, igneous is the solidification of magma or lava. Then we looked at sedimentary, which is compaction and cementation. Now we have metamorphic, so the three types. Now it's metamorphic. Now, how do metamorphic rocks form? They form from sedimentary, igneous, or even metamorphic rocks. Yes, metamorphic rocks can metamorphize even more so, that have been changed. So there are three types of conditions that need to happen to make metamorphism happen. Number one, heat. Number two, pressure. Number three, chemical activity. But the two that you really should remember are heat and pressure. So igneous, solidification, and cooling and solidification of lava or magma. Sedimentary is compaction and cementation. Metamorphic is heat and pressure. Like huge things. Star them, highlight them, something. Heat and pressure. So metamorphic rocks can form two different ways. So the first type you have is called this regional metamorphism. So this happens in over a huge, vast area. And metamorphic rocks are often found in mountainous regions, like, say, the Blue Ridge Mountains, the Adirondack Mountains, Himalayan mountains. So what happens is these rocks experience extreme heat and pressure and chemical activity as the crush pushes them together, creating mountains. And later on, weathering and erosion will occur and expose these rocks that were once buried deeply inside the earth. So, and the next part, well, they're formed. So, these regional things have a couple different ways they're formed. The first way is they're called foliated metamorphic rocks. This is usually formed a certain way. And remember how I said that metamorphic rocks can be formed from metamorphic rocks? Well, this is how, foliated. And I just wanted to show you page 7, right here, it says foliated. So, foliated rocks. They are rocks that have mineral crystals that have been squeezed. Like they're squeezed, flattened. From the side of the rock, you will notice crystals that seem to be flattened. And from the other side, they sparkle. I really wish I could show you these right now because it's really cool when you see them in person. So one of the ones that's like the huge one that you definitely will need to know is gneiss. Gneiss looks really neat. It shows signs of banding. Now, it's the only one that shows signs of banding, and let's just put it this way. The Regents really likes to throw that at you. Which one of these is banding? How do you know? Banding. That's a huge thing for metamorphic rocks. Gneiss has that banding. And you'll see, like, shall not be shiny. That was the sedimentary rock, pardon me. Shale metamorphizes into slate, which then, when even more heat and pressure are put onto it, metamorphizes into phyllite. And when even more heat and pressure are put on it, it metamorphizes into schist. And schist, with enough heat and pressure, turns into gneiss. Pretty cool, huh? So, banding. What does banding mean? That just means that crystals are arranged together in parallel layers. So you can kind of see the banding right here. how it just has like layers of dark and light and dark and light. And the schist looks like salt and pepper. And when it gets flattened, that salt and pepper turn into these bandings, almost like a zebra-ish banding, but sparkly. All right, so the next thing you had regional that does the foliation. Now you have contact. Now, these are metamorphic rocks that form over a small area. I'd say like highlight something to make you remember. Contact is a small area. Oh, pardon me again. They form when rocks within the earth come directly in contact with magma. You know, that hot stuff? Heat, pressure, because it's deep within. There's that pressure, that heat is that magma. Usually these rocks do not experience as much pressure, so they don't show signs of getting squished. So looking at this over time, you have this magma, and right on like this border of the magma, which if it solidifies turns into an igneous rock, right on that border, you have contact metamorphism. So with contact metamorphism, regional, you get foliated. Now, what do you get with contact? Well, this forms non-foliated. Kind of easy. Remember, foliated goes with regional. Non-foliated is contact. So what happens with these? These don't have flattened crystals. Let me move my face real quick. They don't have flattened crystals at all. They do not have mineral crystals arranged in bands. Looking at these are pretty like, they're just there. You can tell by looking at it that they will not break into layers or sheets. I mean, look at it. They're pretty much crystals. Right here, these two types of non-foliated metamorphic rocks right there. All right. So, let's see. This side. This side's better. Which one, when you have these sedimentary rocks, what do they become when they're metamorphic rocks? So looking at shale, if I was to look at shale and I wanted to find out what does shale become, well, you're going to look in the comment section to help you figure it out. And the one that says metamorphism of shale, that gives you the first one I have highlighted, which is slate. So slate, you might notice slate roofs. I know the Mexico High School has slate tiles on the roofs. I can't think of, I think maybe the church across the street from the school has slate roof. That's a lot of shale. When it gets metamorphized, they really like to use that as roofing material. So this next one you have is limestone. Which metamorphic rock okay, let me do it. Which sedimentary rock of limestone, I'm screwing this up. Which metamorphic rock is the metamorphic rock of limestone? So I would look again in the comment section, and let's see right here. It says metamorphism of limestone or dolostone. So both, combination of both, one or the other. Well, what does it make? It makes this white stone right here. And you may notice that this is a lot of flooring, or really nice expensive flooring, or really nice countertops. It's marble. And last but not least, you've got this sedimentary rock of sandstone. What does sandstone turn into? Well, when I look into the comment section on the bottom part, I find metamorphism of quartz sandstone gives you quartzite. All right. So keep an eye on this. Shale goes to slate. Slate tends to be shiny. Limestone marble. Sandstone goes to quartzite. And I'm going to back up a little bit. And then you got this slate goes to phyllite, goes to schist, goes to gneiss. So remember that. All right. So now that you've seen some of these, the pictures aren't exactly the best, but we're going to try and go with it. So let's try and find marble. Remember, marble was this white stuff. So looking for stuff that's white. So this looks, it could be white, but this looks more white. So it's definitely number 4. Although I must say, not all marble is white. I have some gray marble. It doesn't really get pink, but you've got like that gray marble, white marble, marble that has streaks in it. But in this case, this marble is white. And you can think of it like limestone tends to have shells. It's kind of white shells. All right, we're going to look for the schist. The schist has kind of a salt and pepper thing going on. And looking at it, this could, but it looks more like squished pebbles, like almost were round at one point. I'm going to go with 3. Yep. All right, we're going to look for slate. Looks similar to shale, but maybe a little bit shinier. That'd be number 2. Nice with the banding. Kind of looks like a zebra. You get number 5. Metaconglomerate. You're like, Miss Co, what is metaconglomerate? Now, looking at this, metaconglomerate's on the bottom, and it says pebbles may be distorted or stretched. So looking at this, I can almost see like pebbles that once were, but they're kind of smushed. It's number 1. And last but not least, this quartzite, you can almost see the layering of the sandstone. It's number 6. All right, so this is it for the notes. Now that I've got the notes done, agenda for the week. Agenda for the week. We looked at metamorphic rocks. You got the screencast with the notes. You've got the vocab with the Kahoot, and you've got the rocks lab. Don't forget to do the rock lab. Remember, labs, you need 1,200 lab minutes to take the Regents in January. Again, you guys are taking the Regents in January. It's not going to be the full year course. It's a half-year course. So in January, you're taking it. On Tuesday, you're going to have a screencast, like that review screencast with notes that I give you. The activity, be quick and easy right after the fact. And then you're going to have that metamorphic quiz. Again, only open for that day. I'm putting them in red now, so you know it's only open for one day. Wednesday, we're going to do a Unit 2 review on the rock cycle. We're going to have a review activity. That's it. I also want you to study for test. Study for the test. You can definitely study for the test after this. Wednesday, Thursday, it is the test. Unit 2 test. I know we're going through it pretty fast. Unit 2 test is on Thursday. And Friday, be sure to do the pre and post assessments. We're going to do a water cycle with notes. We're starting a whole new unit. It's going to be weathering and erosion. And then you're going to have your vocab Kahoot. All right, guys. So if you have any questions, do not forget, don't hesitate to get a hold of me. Remember, I need to see you once a week on the Zoom meetings, at least once a week. It is part of your grade. You need to do it. If you have questions, feel free to email me. And I hope you guys have a great day.